Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, and in this lesson we'll be learning about how to use Threadmill. In this part that we have on the screen, I'd like to add a thread to this hole over here, and I'll do this by using the option of Threadmill. We'll start by going into our operations and adding an operation called thread milling. We'll choose our geometry, and choosing our geometry is exactly like the way we choose a geometry in any drill operation. I'll simply click on this surface here to pick up the center of that hole, and now we'll go into defining our tool. We'll go into Tool, and then we'll go to Add. When we click on Add, we have two options, whether to pick a thread mill or a thread taper. We'll choose thread mill. Now in this field we have a choice of how we want to define our thread mill itself. We can define it whether it be in millimeters or in thread per inch, and we can choose either by table. If we go by table, we have to choose the standard that we want to use. For example, if I were to click on this button, we have several different standards, whether it be BSP, metric, UN, Whitworth, and we also have from choosing directly from different manufacturers' catalogs as well. Let's choose for example, UN, since the hole that I will be putting a thread in will be a 1/2 inch by 13 thread per inch. When I click on this option, you'll note that there's a table that comes up. I'll simply look for what I need, in this particular case 1/2 by 13. And in this line you can also see what the drill preparation has to be, as well as if it's an external, what the cylinder preparation has to be before I do the thread mill itself. I'll simply choose that and say OK, and all of the fields will automatically be entered according to that tool. My cutting diameter, if this is the actual cutting diameter of that tool, I'll leave it the way it is, or I can actually put in whatever value the actual diameter of the tool is. The next field is the number of teeth. How many teeth we actually do have that will be used for the threading itself. This will actually control the amount of times it steps in, as we'll see later on through the part itself. We have our arbor diameter and the rest of our value as well, and we also have our shoulder length. What's important in the shoulder length is that the shoulder length must be larger than the actual depth of the hole that we'll be using. In the default tool data, the data is exactly like any other end mill. I'll simply select my tool, and then we'll go to our levels. We have our upper level on the top over here, and then we have our depth definition. We have two ways of defining our depth definition. One, either the actual depth of the part itself, of the hole itself, or the amount of threads I want on the wall itself. Either way, whichever one is necessary. In my technology area, we have whether we're working internal or external, and as you can see on the right hand side, the picture changes according to which type of threading you're doing. When doing external, we also have right-handed, as well as internal we also have right-handed or left-handed. You'll note that the major thread diameter is automatically filled in by the table that we had used. We also have complete control of the direction of our cut, whether it be from the bottom to the top or top to bottom. We can do multi-passes by using the rough clear offset, and we can have a finish pass as well. We can use them both at the same time or individually. And we also have start angle. Sometimes there's a specific angle which is necessary for you to actually go into the part itself. So you have complete control of that approach angle as well. In our link area, all we have to do over here is decide whether you want to have a flat approach or an angle approach. And we'll take a look at this at the moment. The actual approach arc is calculated according to the tool that you will be using itself. Now, let's take a look at the simulation. You'll see that my tool path goes in from the bottom, in this particular case, up to the top, and it spirals away around up until it gets to the very top. Now, we'll also take a look at the very bottom of the tool path, and you'll note that it's actually at its approach point already spiraling its way into the part itself. If I were to go out of here and now change this to flat approach and do save and calculate, you'll see now that my tool path has now a flat approach instead of a spiral approach in the part itself. And then when it gets to its contact point, only then does it start spiraling up. Now, as I had mentioned before, the tool path spirals in. Now, if I was to go back to my tool itself, and let's go into the edit information, and let's just simply edit the amount of teeth I have. Instead of 2 teeth, I'll put in I have a total of 5 teeth on the tool itself. So for every spin around, for every spiral that it does around, it actually covers 5 threads. Let's take a look at what happens now at the tool path itself. You'll see that the tool path now spirals in once and only once. This is because the tool path now can, the amount of teeth, cover the entire wall of the hole itself, so we only have to go around one time to do all the threads on the part itself. Now let's go back into our tool. We had defined our tool by using a table. We can also define the tool by the user. When I choose the option of user, then we actually put in all of the information that we need. We can pick what standard we want to use. For example, I can use the UNC standard, and all the information is open for me to put in as I wish. I can put in any value I want here, whether it be 13 threads per inch or 12 or 10, whatever value I want, I can put that in. All of these values are put in by the user then himself. When choosing this as my option for creating a tool, the value in the technology of the thread data will be 0. And this is again something that is put in by the user itself. This also allows you to do special threading as well. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.